In this tutorial, we will be solving systems of two linear equations. We will do this by graphing both equations on the same coordinate plane and then analyzing the graphs. Here is a system of two linear equations. We will graph both of these on the same coordinate plane. Recall that any point on the graph of an equation is a solution of that equation. Therefore, any point that is shared by both graphs is a solution for both equations. Fortunately for us, both of these equations are in slope-intercept form, so we can quickly determine the slope and y-intercept. The first equation has a slope of 2/3 and a y-intercept of -1. The second equation has a slope of -1/2 and a y-intercept of 6. To graph the first equation, we locate the y-intercept, -1. Since the slope is 2/3, we can move 2 spaces up and 3 spaces to the right in order to find more points on the graph. Once we have found a few points, we can draw the line. To graph the second equation, we locate the y-intercept, which is 6. Since the slope is -1/2, we can move 1 space down and 2 spaces to the right to locate more points. Once we have found a few points, we can draw the line. Now that both lines are graphed, we can find the point that is shared by both graphs, 6, 3. This point is a solution for the system of equations. Here is another system of two linear equations. Unfortunately, these equations are not in slope-intercept form. We will use algebra to convert both equations into slope-intercept form. In the first equation, we subtract 3x from both sides in order to isolate the term containing y. Then, we divide each term by -4 in order to solve for y. The first equation is now in slope-intercept form. In the second equation, we subtract 2x from both sides in order to isolate the term containing y. Once this has been done, y is by itself. So the second equation is now in slope-intercept form. Now we can graph both equations. The first equation indicates a slope of 3/4 and a y-intercept of -7. The line for this equation is shown. The second equation indicates a slope of -2 and a y-intercept of 4. The line for this equation is shown. Now that both lines are graphed, we can find the point shared by both graphs, 4, -4. This point is the solution for the system of equations. When a system of linear equations is solvable, there will only be one point that is shared by both lines. However, not all systems of equations are solvable. Let's take a look at a special case. As you can see, these lines have the same slope, 4/3. However, they have different y-intercepts. This means that the system represents parallel lines. As we can see, parallel lines do not share any points. Therefore, this system has no solution. Here's another special case. The first equation is ready to graph, but the second equation is not in slope-intercept form. We will use algebra on the second equation to convert it. Notice how we subtract 2x and 3 on both sides to isolate the term containing y. Then we can divide each term by -3 to solve for y. And at the bottom, we see the second equation in slope-intercept form. Now you can notice that both equations are identical. This means that they will both yield the same line. Since both equations yield the same line, the equations share infinitely many points. Therefore, this system has infinitely many solutions. We have now covered all of the possible outcomes when solving a system of linear equations. Thank you for watching.